Hello, Mario! In this video, I'm going to start to have a look at preparing the Earthworks plan. So first up, this is the Earthworks plan that I've prepared. And you can see it here. I'll just zip it down a little bit there. And this is the Earthworks plan. So one of the first things I did for preparing the Earthworks plan was to draw in the section lines that we did. So this is the 20 metre section line here, the 40, the 60, the 80. So these are all the sections or cross sections that we have done previously with the in previous plans. We can see here that we've got a little bit of a problem in that these seem to be on the outer, so I would need to change that at some point just by possibly bringing all of these wipeouts and what have you, just draw order there and bring them to the front, and that'll sort that out. So that's something that I'll sort out subsequently. I'll also notice that occasionally, or most of the time when I open a new file, that the line weight settings always get put back to a default of 25. I need further investigation of that. I always like to have my default at 0. Okay, and I've got the line weights there displayed. So first things first was to go through and put all the section lines in, and then from the section we could work out where the cut fill line was for each section. So we could measure that out or set the length to that, and then from that I was able to put in or draw in a cut fill line all the way around. So this is the line where the natural ground remains natural and the design starts. In this case here, because I've dropped this cul-de-sac in quite deeply, cut it in so that we've got the houses are all above road level, that means that we're all everything is in cut, and that's intentional. It may well be that I've cut too deeply, and as you can see from the volume that I've just got written there, which I will be discussing in a further video, that 20,000 cubes is probably quite a lot, at around about 1,000 cubes per lot is quite significant. So whether this design ever moved forward at that volume is quite debatable. Clearly, the initial, I've put a cut fill line here because the actual 3% crossfall of the road there would be maintained. Whether there would possibly be some refurb going on with regards to sealants, things like that, but in terms of the cut fill plan, I've just got that there. Also remember that there's also a cut fill, or the end of the long section shows a cut fill line which is out there. So generally, essentially what I've done is just joined up those there to create a cut fill line for the whole thing. Once I've done that, then what I do is I created a couple of new layers, and they are the design contour layer minor and the design contour layer. So design contours major and design contours minor. Now how I've done that is I've used there's a function called the copy to layer function. So copy, I'll just show it coming up here in the command line, copy to layer function. Now how I've used that function is I have selected everything in the natural ground contours. So that's everything in the contours minor and contours major layers, and I've copied those to the new layers I created, the design contour and the design contours minor and design contours major. So I've copied the ground contours layer to the design contours minor, and I've copied the ground contours major to the design contours major. Then once I've done that, I have then trimmed out anything within the cut fill line, because the contours within the cut fill line will be now the new design contours. And so it would probably look, I'll just turn off the, well no it wouldn't, oh, that won't show it, but it will, I'm pretty sure those layers, what layer are they in? I'm pretty sure that these contours here, let's put that on the single click, so these ones here, design contours minor, and then these new layers here are also design contour minors. So I haven't got them in separate layers, but if you can imagine everything clean within the cut fill line that I've shown there. Now the next thing to do is to try and work out where the contours go. And to do this, there's a couple of things. One of the things I've done is with my Excel spreadsheet, I have been able to work out, so in my spreadsheet here, I have been able to work out levels at all of the key points. So if we take here, this is the center line, I've just set up the Excel spreadsheet so that I can, what I can do here is I can work out the right lip of channel, right face of curb, right back of curb, right footpath left, right footpath right boundary, and the right cut fill line. And these are all the levels that would arrive at them by using the typical cross section. Like for instance, the right lip here, I obviously take the centre line level. I actually worked out the left side, so that would be the centre line level, which is W8 minus 3.45, which is the road width, times 0.03, which is the crossfall, and that would give us to the channel. And then from the channel, we know that it's 25mm drop, and so on there. And then the next one would be plus 100 to there, and then the next one across the top of the curb would be the same, and then up to the footpath would be 1.25 meters in this instance, times 0.4. So all of that has been obtained from the using the typical cross section and the Excel spreadsheet. So what that gives us is that each of these points here, it gives us a level. So going back to the cut fill, and I've used a little long 2, I've called it here, but this is my calculation area where I can zoom in and do various things. So just zooming into here, what I then did is, at each of those points, I then keyed in a point, typed a point, and I'll just turn on the points. DDP type puts in a point there, and I like to use this one here as my point thing. So I put in a point there, and you can see that I've put all those points in there, and then I've keyed in the heights to them. Keyed in the heights to, and this is in a layer that I call, this is my cross calc layer, which is turned off, but it's just, it's a layer I set up for the cross sections for calculating them. Now I'm using it here. And so for each one of those, now I can key in the height, and so on like that. And then what that means is that if we look at the line, or perhaps we can look at a contour line, I'm able to then draw a line from each of those points. And then we can see where the contour crosses the line. Now, how I managed to do that, and it's not showing up quite so well here for some reason, how I managed to do that is by using the changing over to the 3D mode, and typically it would come up the top here. I'll just flick back to paper space and just zoom, extents, enter, and go up to here, but it's proving to be a little bit elusive here just at the moment. Oh, because I'm in paper space, go to model space. Ah, there it is, right at the top there. So, as I said, I put in those points, and I started on the left-hand side putting the points in, and some of them I may have deleted subsequently, but I started on the left-hand side, and then and I'll show this later, a lot of the time I mirrored the contour over to the right-hand side and then turned it around. So let's just go up here into 3D mode, and I choose southwest isometric like that, and that immediately scans in here, and because we've got the things like so, it gets a bit congested, and so type in RE for regenerate, and it regenerates there like so, and then we can get in a bit closer and perhaps just have a look at this one here, RE again, till we get down, and then we can see, you can see here how things are going. So here we are, we've got the lip of the channel, we're coming across the lip of the channel, up the face of the curve, across the top of the curve, and in here to the footpath. Now if we look at this line here, and you'll see that I've got the properties window open, you can see that this line here goes from an RL of 27.364 to 27.424. So the contour that would cross there is this contour here, which is the, we can see that there would be a contour crossing there, and I've used these magenta lines here. The crossing there would be the 27.4 contour. Now, how to find where the 27.4 contour crosses is, what you do is you just maybe, I'll just show you here by drawing a line, you just go there and you have your snaps on to nearest, and then if you look down in the bottom left, right in over here, you'll see the coordinates. And so all I did there was just move along till I got a coordinate of 27.4, and then click the point there, and that found the point, the 27.4 contour, on the line between those 2 points. And obviously we can go this way as well, and you can see appearing down the bottom there the coordinates. Now if you wish to turn the coordinates on or off, there's a switch over here that allows you to do various toggling, and there's the cursor coordinate values turned on there. So again, if you want to see where the contour crosses, and again, just using the 3D mode, I found flicking into 3D mode, it takes a little while to get it set up, and then again there you can see. So that enabled me to, and I'll just go back now to the top mode. That enabled me to get my position of where my coordinates were. And here we are back here now in top mode. Again, we've got to, just because we've got all those points there, it can get quite conglomerated. And there we go. So by keying in all these points, I am able to find where the various contours cross. And again, through here, this is the 10% batter up to natural ground from the boundary, and again, it's just a matter of joining them in. Now, then to get the ones on the other side, what I did was I just mirrored them across and rotated them and adjusted them just to get them approximately right. Now there is some problem with the curves, because when you put a curve into AutoCAD, it'll only accept levels, one level for the curve. So what I did was I approximated the curves for straight lines, and then once I'd found out roughly where the contour went, as you can see here with the magenta, these are the ones with the curves, where they went with the magenta lines, each contour I then just put a polyline on top of it, and like so there, and allowed for the curve. So that curve, the straight line was back there, I just pulled them down over to there, like so, so that I then approximated through the curved ones there with a polyline. And I in fact did that for all of the contours. Once I'd done them in line to line like so, I then put a polyline over the top, and that was my final contour. And then mirrored them over to the other side, although you could calculate them all out. Now this all works pretty well just for the straight line bits of the road, but up round the cul-de-sac head things get a bit difficult. So again, I went back to my Excel spreadsheet, and this is another section of my spreadsheet here, and what I did here was, this is just a little calculation that I can do here that enables me to just calculate from the lip of the curb, through to the boundary, and so I can just put any value in here, and like, I don't know, 27.114, which is the one there. Put any value in there, and then it'll calculate. That's the lip of the curb, channel of the curb, top of curb, back of curb, footpath, and boundary through to there. And then I could have put a cut fill in there, but I didn't know quite how that was working. So that enabled me to create various points up through here that enabled me to track where the various contours would go. Notice, point to notice is that the contour, it comes in and it goes round and it comes out. So it's pretty important that you sort of think about where the contour is going to go. So I did that at the cul-de-sac head, which gave me some more points that I could use for my contours. And also I did that here at the intersection, which enabled me to track where the contours were going. Now the contours are pretty much an approximation, and I created another little tool down here, which I just used this little tool. I created it as a group because in the 1 to 10 slope up to the thing, obviously the contours rise 0.2, so they're going to rise 2 meters. So I just made this little guide here, which enables me to work out where the contours were. So in some cases, particularly down here at the intersection, where I was trying to trying to just sort of work out where the contours were going, I used this little guide so that I could draw my contours, just to making sure that I maintained approximately the 10% thing. So that's got all the contours there done. I think that's a few of my techniques. One is to draw a line and then use the 3D to interpret where the contour intercepts, to use mirroring to mirror from one side to the other. Around the curve it was a bit tricky, so I did the mirror and then rotated them around a bit, and then used my little guideline there up like so. And you can see that you get this typical sort of shape here for the contours, which depends on the grade of the road. So you've got the upward shape here, and then the reverse as it comes up through here. So going back to the Earthworks plan, which is where we started, that's how I got my contours in there. Just use the same labelling for the design. and showed them, you know, the working there within. So that gives people a pretty good design idea of you know, what's happening, where the grades are, and it sort of depicts the extent and nature of the earthworks. So then from there we're able to work out the volume, and I'll show you how to do the volume in my next video. So this is that's the earthworks plan. So thanks very much, and we'll see you next time.